Alrighty, folks. Hey, Phil Zito here. How's everyone doing? So, today's episode of SBA TV, we're going to be talking about hot water control. So, we're going to be diving through boilers. We're going to be talking through hot water control. We're going to be talking through kind of how we do staging. We're going to talk about a variety of different things. Today, we're once again be using the new electronic whiteboard. So, we're going to have a lot of fun with that. And my name is Phil Zito, founder and CEO of Smart Buildings Academy. And like I said, today we will be going through hot water control. So I'm going to move us over to the whiteboard and let's start to talk through boilers. Let me move the screen over so I can see your questions as they pop up. Definitely engage. Let me know. I know we're not in heating season really anymore. We're now in cooling season, but, and I'm going to move this screen over just a little bit, but still, nonetheless, hot water control is an important thing to understand because just like when we're talking about chilled water control, you will still have the need for hot water, even during the summer. There will be process loads that require hot water. All right, so let's talk through this, especially with all of the new IAQ requirements where we're starting to really utilize enhanced outside air ventilation, which is going to require dehumidification sequences, which in turn is going to go and require for us to use heating and hot water. All right, so how does a hot water plant work? Very similar to a chilled water plant, except for that you only have a primary side coming out of the boiler. Right, and that's what we use in order to produce heat. We either use steam boilers or we use hot water boilers. We're going to start off with hot water boilers. We're going to talk about primary and secondary control with the boilers. We're going to talk about boiler fire rate control, enable sequences, and then we're going to move on to steam, and we're going to talk about tubular heat exchangers, not plate heat exchangers. With steam, we're going to talk about 1/3, 2/3 valves. And then if we still have time, we'll talk about using a hot water plant centralized and then using plate heat exchangers within buildings as kind of a campus-wide hydronic plant. That's the plan. Okay, so hot water boiler. At the end of the day, the hot water boiler, unlike chillers, which just simply require electrical power for most chillers to go and enable the compressor to run, unlike chillers, boilers require three things, right? They're going to require a fuel. They're going to require a combustion source, which is the fuel, sorry. They're going to require some form of oxygen, most time. And they're going to require control. Now, that being said, there are electric boilers that use resistance. There are other boilers that necessarily don't require oxygen, but we're going to have our fuel, our oxygen, and our control, right? So you've got gas-fired boilers, which are going to combust, and they're going to use oxygen in that combustion process. Typically, that's going to be one of our most common ones, right, is gas-fired boilers. So what will happen is you'll have the flames down here. You'll have kind of the tubes right here with the water in it. The flames will burn. The water will heat up, and then the water will go out of the boiler. Pretty straightforward. What will happen is that the oxygen will come in and you will control the oxygen rate, and that oxygen rate will go and basically combust, right? You'll take your gas, you'll go and fire it up. The oxygen will help you go and do the combustion process, and you will create heat. Because when you're burning gas, when you're burning wood, when you're doing whatever, you are going to go and create heat. I'm going to just check what this comment says real quick. Look at that board. Yeah. Hopefully it's looking nicer. I'm trying to mess with the lighting to figure out kind of what lighting best gives it, whether the white light gives it the best or the more oranger light. I'm feeling like the more oranger light works better. So as I was saying, you got fuel, oxygen, and control. Control is going to be two things, right? We're going to have our enable, and we're going to have our fire rate control. You don't always have fire rate control, but you almost always have enable. So what will happen is just like the inverse of chilled water plants, we will go and look typically at outside ambient or building load calculated in BTUs, and then we will go and enable the boiler. So we're going to have kind of OAT, or we're going to have a BTU load that is causing this enable to trigger, right? And then once this enable triggers, that's typically like a RIB U1C relay that is connected to the control panel, typically sitting at the front of the boiler, and that RIB U1C will enable the boiler. Now, we also have the opportunity to vary the fire rate. Now, I'm not going to get into, BACnet and all of the Modbus integrations and BACnet integrations that we'll see with boilers potentially. Most of the time in the world I grew up in, we used, a 0 to 10 volt signal, or we used a 0 to 135 ohm signal that would basically adjust and would reset our fire rate. Our primary fire rate is typically going to vary between 160 to 190 degrees, right in that area. And then our secondary rate, which we'll talk about, will look a little differently. But what happens, right, we enable the boiler, we enable the pump sometimes. There's a circulation pump, a CP, that's usually interlocked to the actual panel right here. Now that CP is enabled typically when the boiler is enabled, and when it proves flow, then we'll move into ignition, we'll move into low fire, and then we'll move into high fire unless we have variable fire rate, okay? So low fire being a low amount of fuel being burned, high fire being a high amount, and the boiler itself will control to its primary temperature, all right? So then going a little bit further on this, what we have going on is we have a mixing valve, right? We have a mixing valve here and a secondary loop. Just like with the chilled water plants, we have our secondary loop, and our secondary loop will typically have a VSD on this pump, and this VSD will enable us to vary the speed on the pump. And then the mixing valve here will typically be tied most likely to an OAT reset. So, 50 degrees equals 140 for the secondary chilled water or secondary hot water supply temp. And then, 30 degrees equals 180. And this will be our secondary hot water set point. Okay, and we will control that. Now, the VSD will typically drive to a pressure, and that pressure obviously is going to vary as we open and close valves. Now, there's more you can do to this. You can do the old calculation of delta T times 500 times GPM to do a BTU load calculation, and you can stage up and down boilers. The thing with staging boilers, though, and we'll talk about this, is you have to understand, first, do you have equal BTU ratings for your boilers? So boilers are rated in BTUs, not in tons. And so do we have equal BTUs? Because if I want to stage these boilers up, and I want to stage them up, there's unison, there's lead lag, and then there's kind of staged where you just step them up. I like Unison Control, where you run both boilers in unison and you vary their fire rate and you track, and in most cases that can work really nice. But oftentimes you'll have boilers that are added after the fact and they don't have the same burner capacity, so they don't have the same BTU capacity, they don't heat up as quickly, or they heat up more quickly. And so then you come into a scenario where you don't want to run them in unison because you can actually end up overshooting. So what I will tend to do is run a boiler to max and then bring on a secondary boiler as required. But the problem with bringing on a secondary boiler, something you need to be cognizant of, and we'll go into steam in just a second, is if we are running a secondary boiler, we can't just fire it up. We have to let the water circulate through. We have to let that boiler heat up. And once that boiler has heated up, like the water inside it has heated up, then we can fire up the boiler. Otherwise, we risk condensation, we risk all sorts of issues with boilers. Okay, so we talked about secondary control at a high level. We talked about boiler control at a high level. I'm going to clear this off and we're going to talk about steam. And give me a second here. Okay. So from a steam perspective, if we recall when we talked about refrigerant and we talked about phase changes and state changes of gas to liquid and liquid to gas, we talked about how doing that causes a tremendous amount of BTU gain and loss. Well, the thing with steam, and I don't have this memorized, but basically for water, right, if we go from 212 to minus 32, I think that comes out to 180. So for every pound of water, we have 180 BTUs, if I remember correctly. For steam, if I remember correctly, it's around 900-ish per pound of steam. Okay? So because we are going and changing the liquid into a gas, that act of changing that liquid to a gas requires a tremendous amount of energy. And thus in steam, we have a tremendous amount of energy contained in steam. That's why we use steam in areas where we're doing 100% outdoor air units and we immediately need to impact that airstream, or we are distributing through a campus environment and we want to send that steam throughout the campus and then use like tubular heat exchangers to go and warm a hot water loop for a building. So what we'll do with steam typically, right, kind of the same boiler concept, and then the steam will come out, and that steam usually will go to a tubular heat exchanger, and that tubular heat exchanger will have steam on one side, right, and then it has the water on the other side. And the water gets heated up. So we heat up, and then we have condensate, and we deal with that as well. But I'm not going to go into condensate control at this time. So we will heat up a building hot water loop. And that building hot water loop, and we'll have several of these heat exchangers throughout the campus, right? And they will go to each one. And then what will happen on this, we'll typically have something that, let me see, yeah, I'll blow this up a little bit. It'll look more like this, where we have a 1/3 valve and a 2/3 valve going to this heat exchanger. And what we'll typically do is we'll open the 1/3 first, and that's where most of the steam is going to come through. That's why if you've ever done steam control, you'll know that within the first 30% of opening that 1/3 valve, you typically get the most shock on the process variable. So the process variable in this case being the hot water, but in an air handler, that process variable is usually the air that is on the leaving side of the steam coil. So we'll control that 1/3, and what we'll do is we will typically use that 1/3 and we will drive that till it hits 100%, right? And then when it hits 100%, what we'll typically do is then we will go and we will switch to the 2/3. So we'll close off the 1/3, open up the 2/3, because 1/3 is 1/3 capacity of steam. 2/3 is sized for 2/3 of the capacity of steam. So that's 66% and that's 33%. So we'll close off that, we'll open up that 66%, and then if we're still not getting that 66%, then we will start to open up the 1/3. How we'll typically do that is a PID loop with some scaled outputs to drive the 1/3, 2/3 outputs, and then we'll use some staging control as well. So that's typically what we're doing with this 1/3, 2/3 concept with steam, whether that's in an air handler or whether that's in the tubular heat exchanger as well. So that is the basics of hot water control. Just to recap, you have boilers. Boilers use fuel, they use oxygen, as well as using control. They go and produce heat. That heat is then distributed throughout the building, right? That heat is then distributed through the building through coils, just like with chilled water systems. We have primary, secondary loops with most boilers for most decent sized buildings. We get into steam in our larger buildings, especially buildings that have 100% outdoor air dampers, like hospitals, things like that, where we really need to impact that preheat for that 100% outdoor air as fast as possible. We use that 1/3, 2/3 concept to go and actually drive the heat and control the heat from the steam. And then in the case of building distribution, we're going to be using tubular heat exchangers. So that being said, I'm going to step over, see if we got any questions, and we'll go from there. All right. Tough to see what I'm writing. Okay. Well, that's good to know after the fact. Let's see then. If that makes it tough, then I wonder if that makes it easier. Let's see. Does that look a little easier now? Let's take a look. I'll see right off the bat. This thing is taking some getting used to. So it still looks tough from my end. Oh no. Maybe actually that's causing it. I wonder. Take a look at that. Definitely got to figure out the screen. Figure out what is causing it to have this issue. Because on my end, it looks good. Well, we'll figure it out. I'll re-record this because I can see where it does definitely look hard to see. It's a learning process. All right, well then, I'm going to actually go and I'm going to redo this video on SBA TV episode 33-2 so that we can figure this out. All right, well, folks, I apologize that it didn't come in the best, but we'll get it figured out. All right, take care.